What do you got?
I just had like when you're doing like those sequence problems like that are like A through G, and it asks he wants to keep the box moving at a constant velocity, you would be using kinetic friction, right?
Correct. Yep. If the problem is about keeping the box moving at a constant velocity, absolutely, it's kinetic friction and what else? If it's constant velocity,
Net force is 0.
your net force is 0.
Okay, and then if you're trying to get it to move, you use the static.
Good. Yeah. Operative word being get it move. Yeah. If you're trying to get it moving, then yes, you got to overcome static friction and then any other forces that could be resisting the motion. Good.
Okay, can we do? I had. Is that E? Yeah. E. When
5e.
Yeah. It like. I think.
But I'll just do it in a minute. So hang tight for 1 second. Okay. What ones do you need to do besides D, AJ?
C.
C. What else? Other ones? Okay, cool. So let's do that. So for number 5, so here's the deal then. For, what do we got? 4.4, number 5. All right, so this whole problem is about a box. I think it's a 45 kilogram box sitting on an inclined plane, right? So is everybody good with the fact that you have to find your force of gravity and then find your parallel and perpendicular components? Like, can I just kind of gloss through that? Is everybody okay up to there? All right, so if you do that, your FG parallel here ends up being negative 283, oh well, yeah, we can call it negative 283.5 newtons. Your perpendicular component ends up being negative 337.8 newtons, which means my normal force is also 337.8 newtons. Cool? All right. What should my next step be, regardless of sort of what's going on? There's something that you should probably kind of automatically do. Yeah, find your friction forces, right? So in this problem, we know that our coefficient of static friction is 0.48, which means your force of static friction max is 162.2 newtons. And your coefficient of kinetic friction is 0.36, which means your force of kinetic friction is 121.6 newtons. Everybody good up to there? All right, now, there are some unfortunate coincidences in the way these numbers work out, and I've since rewritten the problem to avoid that. But somebody asked about C, is that right? Okay, so question C says, and I quote, find the force needed to make the box slide down the ramp at a constant velocity. All right, so for part C, I want it to go down the ramp at a constant velocity, right? So, what should I do to my drawing to indicate that it's moving down the ramp? If it's moving down the ramp, what has to be true about friction?
That's kinetic.
You got to have kinetic friction going up the ramp, right? And the kinetic friction has to be 121.6, right? Everybody good up to there? Please. Wait, what? Just coefficient of friction times the normal force. You good?
Yeah, I see coefficient.
It's okay. Everybody happy? Sarah, you okay? Okay. Okay, so now I need to make sure that my net force is 0, right? So net force is force of gravity parallel plus the force of kinetic friction plus the problem said how much force is needed. In other words, how much force do you need? So Fu. Aha. All right, so our net force is 0. Fg parallel is negative 283.5. Force of kinetic friction is 121.6. And we're trying to find the force of U. Follow? All right, so if you solve this, it turns out to be 162 newtons, which is really aggravating. It's actually like 161.9 newtons. which is unfortunately, by a freakish coincidence, almost the exact same thing as your static friction max. And that's total coincidence that that happened. All right, so is everybody good with the process I followed here? Yeah, AJ.
It's 14 to find out the 14.
Yeah, that's, oh, yes, thank you, I did not, yeah. Sorry about that, thank you for asking. All right, problems with C. All right, D, did we need to do D or just E? I mean, D and E are very similar.
I had E, but it wasn't that I didn't get the problem right. I just thought, I had like 5.2 divided by 1.2 equals 4.33. I think like the difference between D and E was, what was the difference between D and E? Like
Different accelerations.
Okay.
In E, the acceleration is 5.2, and D,
Okay.
the acceleration is 1.2.
Okay, so I was wondering if you could divide those accelerations and then multiply.
Let me talk to you after class. You're gonna mess everybody else up.
Okay.
Okay, because you're doing stuff weird. And it seems to be mathematically working in many cases, but the physics is sketchy.
Okay.
All right, so we need to talk more. All right, why don't I do D the correct way? That would probably be helpful.
No, I did it the correct way. I just wanted off to do it this way.
Gotcha. No.
Okay.
How about that? Because if you hadn't already done D, do you know what I mean? Like there's sort of no... All right. So does anybody want me to go through any other part of 5? This is like, to me, number 5 is like you've had one of these on every homework assignment, you have a target check like this, you have to know how to do number 5. Anybody need me to do more of it?
Yeah, could you go over like F and G, please?
F and G. Yeah. So F, if you're trying to get the box sliding up the ramp, it says it's at rest at the bottom. If you're trying to get it to go up the ramp, what 2 forces do you have to overcome, AJ?
Well, 20 and
Not if you're trying to get it moving. To get it moving, you got to overcome static and
parallel.
the parallel component. So just add those together. Does that make sense? Are you lying, so I'll leave you alone?
Not yet.
Okay. So that's F. And then G is exactly like C, except in G we're trying to make it slide up the ramp at a constant velocity. So how does that change this drawing if I'm trying to make it go up the ramp at a constant velocity?
Can you just flip the entire thing?
Well, no, because gravity's still pulling down the ramp.
That way. Stupid question.
No, you're not at all. How do we change it? If it's going up the ramp,
You change around the
kinetic friction goes down the ramp, right? And then you again set your net force to be 0. Good?
Yeah.
All right, when do we get out of here?
25.
25? Okay. All right. Any problems on 1, 2, or 3? Yeah, so.
Just for 3, for B,
Mhm.
like I originally used just the 70 kilograms. I was like, when do you know you do the combined mass?
So if you just use the 70 kilograms in number 3,